Hello, this is Dan Nunes discussing the water gun sensory turret. This project was done by Gianmarco, Chia, Jean, and myself. We decided to do this remote, so all four of us created our own prototype. This is my cat, Akasha, and I sure love her. She's a great cat, but unfortunately, she thinks she belongs on furniture that she doesn't belong on, such as our coffee table, our dinner table, and even my kitchen counter, where I prepare food. When Akasha gets on our furniture, we do keep a bottle full of water available so we can spray her, which does correct the behavior in the immediate, but unfortunately, that lesson doesn't last. That's why I felt this would be a great group to be part of. What we decided to create is a turret that will sense motion and have a water gun attached. I thought this would be an excellent project for Akasha to be able to keep that lesson learned even when I'm not home. For communication purposes, we decided to use Discord, and that way we were all able to communicate with each other, compare notes, talk about our wiring, and help each other through all the pitfalls as we all worked on this project together, but separate. Being that there were multiple prototypes, there were different hardware used in some. This is the squirt gun that I used for the prototype that I will be describing throughout this video. We discovered two projects that had already been completed and there were guides to online. One was for a motion activated gun turret. The other was a motion activated camera base that would turn a camera towards the motion using multiple passive infrared sensors. The camera base that would move did come with a guide to show us some good idea of how to do our wiring, and we did build this circuit, multiple iterations of it, and tested it each individually. During this portion of the build, we learned a lot about the different components that were used, the application of Ohm's law in a circuit, and the need for a capacitor to stop power spikes. Definitely a lot of research and discussion went into how to properly wire and program an Arduino. When I dismantled the squirt gun, I saw that it was a pump operated by a DC motor with a push button to connect the circuit.
So I thought I had it
Initially,
good.
I was going to use a new DC motor that received in my kit, but the gears for the water pump only
like a
attached with a
D-shaped
D-shaped rod in the center of the
catch that.
motor, and
This one
unfortunately, I
is
did
a
not have
round
that.
pin.
So I did
So I
have to
leads back into
solder this one into my kit. This created a new issue with the amount of power it was going to take to operate the gun. After doing some research, I decided the best solution would be to add a relay and to power the gun separately on a 12-volt power supply and have the relay controlled by the Arduino itself. Initially, we used a servo motor, but it only had 170 degrees, so I switched to a stepper motor, which had a high degree of control and could go 360. We also, of course, had to learn to use the passive infrared sensors. That was quite a learning curve, but they are fantastic and inexpensive little devices.
Field of the green. Okay. I'm going to go in the field of the red without trying to hit the blue, hopefully, but who knows? It's pretty sensitive. Okay. And then finally, I'm going to go into the field of this blue light, hopefully not get the red. Okay, perfect. So I think I've got the circuitry for the motion sensors down. We can use them as input, outputs, whatever. Um, that's been a big step up to.
With all of the systems functioning, around this time is when I decided to start to Frankenstein up my monster. This is a CD case that I cut holes into and mounted my 6 passive infrared sensors to. I did some testing at that time. One of my sensors actually ended up broken, but I had hot glued it in, so I did lose one. Moving forward in the future, I would probably make it removable and replaceable. After I had mounted that in, I used a Dremel to cut the plastic to give me access to the wiring. I then used a portion of the remaining plastic to house the control for the stepper motor. I then also used a piece of cardboard to create some structural support to hold the weight of the gun and the water reservoir. After a few attempts at soldering, I decided to add the breadboard to the prototype. So I adhered it to a piece of cardboard with the project, as well as the Arduino and the power supply and the small mini breadboard for the relay system. I then used 2 CD spacers. One I adhered to the base, and the other I adhered to the stepper motor column to adhere then the water reservoir and gun to. It was then that I decided to start running tests. You'll see here some video of it following me, and you'll be able to hear it fire. I did not, however, have a water reservoir on it, as I was still testing. The way the system was designed and the way it was coded, once it turns on, it calibrates the sensors for 30 seconds. It then reads the readings, and when it has exactly one of the sensors have a motion reading, it then will turn the motor, wait for about 2 seconds, fire for a third of a second, and then return to its starting position. There is then a delay for the sensors, so they disregard any motion until that delay is achieved. I never did attach the water, but I did get the model functioning fairly well. I'll go ahead and get some screenshots of the code at this time. We can go over some of that as well. As we were working remote, we added a lot of comments so we could all follow the same code. So as you'll see, it's very, very detailed. Almost every line has a description of what it's doing there. We did have to populate a lot of arrays we used for these sensors. Also, we did have to get a timestamp for our delay functions to work. We then populate the arrays and we make sure our serial monitor is started. There is some monitoring that was going on. And then we also want to make sure to set the defaults in the setup loop. The programming for the loop was interesting because with the 6 sensors, we needed to iterate each one on each pass. However, not always would we want it to do anything. So there was some very clever conditional statements for these loops. And then finally, we get to the portion where it controls the relay for the gun itself, as well as the stepper. So the beginning loops are all about the sensors being either in a motion sensed state or in a no motion sensed state. But once we have narrowed it down to only one sensor currently reading a high setting, it will then trigger the next portion, which is this, which will control the stepper to the angle and then allow the water turret to fire or the pump to operate long enough to shoot some water, and then it will turn back and go back. I hope you've enjoyed, and any questions I'll be happy to answer.